So at this point, you should hopefully feel pretty comfortable with adding routers and switches and frame relay switches into your topology, into your GNS3 network. So you might be getting to the point where you say, you know what? I'd really like to add a host into my network. I'd like to have a host for a variety of reasons, maybe to ping back and forth or to do some other types of testing. Now let's step back for here for a second. You might wonder, well, Keith, why do I need a host? I mean, if I just want to do ping tests, or if I want to generate some just test access lists or something like that, can't I just plug in another router and ping from the router? Well, certainly you can do that, but keep in mind one thing. Anytime you plug a router into your topology and then you start it, you're consuming another instance of router memory. If that software image that router is running takes 512 megabits per second, let's say it's a 7200 series router, now you're just eating up a lot more RAM in your laptop simply to have some device that you can ping from. So for here, for something like that and a lot of other useful reasons, I'd like to talk about the VPCS, the Virtual PC Simulator, that's included as yet another built-in node within GNS3. Now I've been using this quite a bit throughout the various topologies, and I've been promising you, well, I'll get to it. Well, now is our time to talk about it. So let's talk about it a little bit. So first of all, this particular node is available right here in the Browse End Devices section. So that's where you would find this. So click on that, and then we're going to be using VPCS. So you just drag and drop it on just like you normally would. Now these, unlike your built-in Ethernet switches and your built-in frame relay switch and everything, these you can turn on and turn off. And notice that by default it's deactivated. It's turned off. So let me get rid of this one here. So I've already got 3 instances of my virtual PCs in this particular topology, and I want to show you some of the real power behind this. For example, let's start out with PC number 2 here. And in this particular PC, I just want to give it a static IP address and mask and a static default gateway. Real easy to do that. So just go ahead and double click on it to open it up. And this is what your console window will look like. It actually has a pretty intuitive help menu, and I like it a lot. Just type, for example, the question mark, and you can see all the different options are available to you here. So in my particular case, I say, well, I want to add a static IP address. Well, we can see from here that IP is probably what I want to do. IP what? What should I do? IP, and you can see it actually gives you an example. IP, the address, the mask, and then the default gateway. So in my particular case, if I want this guy to be 4441, I would just type IP 4.4.4.1/24, and then its default gateway is 4.4.4.2. So you can see it's a little bit of a different syntax than typing an IP address on a router's interface, where you actually type IP address. Here you just type, as you can see. Now there's one, before I go any further with VPCS, one very important thing you have to remember. Let's think about routers for a second. If you make a change in your router's configuration, you're making a change in the running configuration, right? So what happens if you stop that router and you haven't saved those configs, or you completely stop your project? Anything in your running config that has not been saved is gone. It's wiped out. So that's why, as hopefully by this point in time you know, with routers you should always issue the write memory command or the copy run start command after you make changes. Well, in a similar way, these virtual PCs, when you make a change to their configuration like I just did here, you have to save it. If you don't, the moment you turn off that virtual PC or the moment you exit from your GNS3 project, whatever you configured your virtual PC for, his settings will be gone. It'll vanish. So how do we save his settings? It's simply the save command. And that's all you have to do. So remember that with your virtual PC, to issue the save command whenever you make a change. So that's a way of configuring a static IP address, mask, and default gateway. What about over here, PC number 1? I want to configure him as a DHCP client. Well, this is another powerful thing we can do here within VPCS. So I'll just double click on him. So I'm on PC 1. And now, if I do IP question mark, I can just do IP DHCP. That's all I have to do. Now there are some options if you wish, but if you just do IP DHCP, the moment you type that, it will send out a DHCP discover message and attempt to get an IP address. Now this guy already has an IP address, as you can see, 1114. So let's see actually how this works in action. So number one, let's try releasing that address and getting a new one. So IP DHCP, and it says right here, -R, actually -X is to release the address. So -X, show IP. Okay, so now we have nothing, right? So -X was to release the address, and now it's gone. Still remember the DNS settings and the DHCP server, but the address is gone. So how do I get a new one? Just IP DHCP. I'll explain to you in just a moment what these letters mean. And there we go. So what did those letters mean that I was looking at? This is actually showing you the DHCP decode. This is the discover, and then he sent another discover, and then he received a DHCP offer. Then the client sent out a DHCP request, and the transaction was finished by receiving a DHCP acknowledgement. And what's kind of nice is you can drill down even further than that. If I do IP DHCP question mark, you'll see I can also do -D to actually get a packet decode. So let's try that. IP DHCP, I want to release my address, and -D, I want to see the decode of it. And there we go. See? So he sent out a DHCP option 53, which is a release message. And now I can do IP DHCP -D to actually watch the whole process in action. So now he's sending out requests. There's the reply. And then we're done. So let's go up to the top here. Okay, so the first message was a DHCP discover. Then he sent out another discover. And then we received back the offer, and we can see all the information that was included in that offer. Then we sent out a DHCP request, and the final step in the process was a DHCP server sent back to us a DHCP acknowledgement. So the -D option is very useful in this particular case as far as DHCP is concerned, if you want to actually watch the DHCP transaction. Now you might be wondering, well, wait a second, Keith, who's the DHCP server in this particular topology? Well, as you go through your CCNA studies, one of the things they're going to expect you to know is how to configure a router as a DHCP server. I'm not going to go into the details of that right now. I will show you that I've done that on router 2. If I show you his configuration, right up here towards the top is the DHCP configuration, configuring this particular router as the DHCP server. So that was already pre-done. Let's get back to VPCS here for a moment. So another powerful tool of VPCS, you can ping from it. For example, I can ping from PC1 to PC3 to see if my routing and frame relay and everything is set up. So let's see if PC1 can ping 5551. Let's see if it works. We're getting a timeout, and then the ping is successful. Now you might be thinking, okay, Keith, but big deal. I mean, I could ping from a router. Why use this virtual PC? Well, the virtual PC, for one thing, uses a lot less memory than another router instance does. So yes, you could have put a router into your topology and had that router set up as a DHCP client and watch the DHCP transaction. Sure, you could have done that. Sure, you could ping from a router and watch that and test your access lists and stuff. But remember, that router is using up a lot more memory in your laptop than VPCS is. And there's things you can do from here within VPCS that you can't do within a router. For example, look what happens if I type ping question mark. I can do UDP pings. I can do TCP pings. I can set any, if I'm doing a TCP ping, I can set any of the flags within the TCP header. What if I'm testing quality of service and I need to have a packet generator? I want to see if my quality of service policers or markers or stuff are working correctly. Well, how would you create a packet generator out of a Cisco router? It would be kind of hard to do. A ping's not going to do it. But here with VPCS, I could ping via UDP and do it like every 5 seconds. And then I could use the -T option to say, just keep going. For example, ping. Who do I want to ping? 5551. Now I want to do -2 because I want to be in UDP mode. And then I want to do -I, and I'll have those pings go out every 10 milliseconds. That's -I. And then I'm going to do -T. Keep those pings going until I stop them. And there they go. Now let's keep running with them for a moment. Let's keep letting them go. Now if I go over my router, router 2, on router 2, let's go ahead and check out those pings are going through him right now, and they should be coming in fast Ethernet 00 and going out serial 2/0. So if I had some sort of policer or something else like that configured for quality of service, maybe I applied it to serial 2/0. Let's see what the actual output rate is right now, considering massive UDP pings are leaving on that interface. All right, so let's go to router 2, show interface serial 2/0. We can see that right now the output rate is about 16,000 bits per second. Now I tried this before I did this recording, and if you wait, about 5 or 6 minutes, this will get up not too far. It'll go, I waited for about 3 or 4 minutes and it got up to about 64,000 bits per second. But as far as just QoS testing is concerned, that's fine, right? If you just want to create a simple policer and try to police this down to 3 kilobits per second or 8 kilobits per second, you could do that. But in order to test a policer, you have to have some traffic coming in to police it. So this VPCS can be used to generate that traffic. But we're not done yet. So let me go back to my VPCS, Control-C, break out of it. For you aspiring CCNA candidates, you're going to be learning about Cisco access lists. How do you test your access list? Well, certainly you can create simple access lists like blocking telnet or blocking ping, because telnet and ping traffic is stuff you can source from a router, right? You can jump onto a router, and from that router you can type ping or telnet and then see if your access list works. But what if you want to create some more complex access lists that are maybe blocking or permitting certain TCP ports or UDP ports? In that case, how would you generate the traffic to actually test that access list? You could do it from right here within VPCS. As an example, on router 4 here, I have created an outbound access list on fast Ethernet 00. And that outbound access list is permitting all traffic except UDP traffic going to port number 99 as a destination. Show run. So you can see here I've applied the access list as an access group outbound. And if I go down to access list 101, here is that access list, denying all UDP traffic from the 111 network to the 555 network if the destination UDP port number is 99, and then permitting everything else. So how would I test that? Well, let's go back to my VPCS. So ping, question mark. All right, so why don't we do ping 5551, that's the remote PC, and why don't we do -2 for UDP, and then let's do -p. Notice it's a lowercase p here. Very important that you select the lowercase p for the port number as opposed to the uppercase p for protocol, which is the IP protocol in the IP header. So I'm going to do -p, and let's start out with a port number that should be okay. The access list should allow UDP pings going to destination port 90. Might get a timeout for 1 or 2 of them, but then they should work. There we go. So now they're working. Now let's test to see if the access list works. Let's change that destination port number to 99. The access list is supposed to drop that. And it is. We're getting communication administratively prohibited. So this is a great way to also test your access lists. There's a lot of other things this can do here as well. One other thing I want to show you, which is really neat. If you just do set question mark, you'll see that one of the options is the set dump option. So you can do set dump all, and what this does, it's actually like doing a debug packet all on a router. This basically says now any packet that this PC sends out, whether it be a UDP ping, a TCP ping, whatever, I want to see all of it. So for example, let's do that same UDP ping I just did. See, now we get a lot more information about it. We see the the 3332, so that's the actual address of the router that has the access list on it. We see the time to live, we see milliseconds, we see the ICMP type code. Okay, this isn't that big of a deal, but look at the real power of this. What if I want to test out TCP? Maybe you just learned about TCP and you want to see, okay, I've learned there's this TCP three-way handshake. I've learned a little bit about the TCP flags, so I want to see some of that stuff in action. Well, we can do this. Ping, question mark. Let's do ping 5551. And remember, we still have the set dump all configured, right? That didn't stop right there. Set dump all is sort of like a debug all in the world of VPCS. So we'll do ping 5551. Let's do -3 for TCP mode. And why don't we do that's it. We'll just do that. But TCP pings to 5551. Okay, so something is blocking this. Can we ping 5551? Yeah, we can still ping it. We just can't do a TCP ping. Sequence 2, 5551, -3. -3 is supposed to be TCP mode. All right. Well, let's go over to our routers real quickly and troubleshoot this. First of all, let me look at my access list on router 4. So I'm denying UDP. I'm permitting all other IP. So that should be all right. Okay. Let's now go over to the remote PC of 5551 and let's verify that he actually has an IP address, and he is 5551 and his default gateway is 5552. All right, that looks good. So there's no reason I can think of at this point why those TCP pings were not functional. Let's set the dump to off. Set dump off. That's sort of like an undebug all in the world of Cisco terminology. Ping 5551. Okay, well, -3 should be TCP mode. And just like a Cisco router, you can use the up and down arrows on your keyboard because it does keep a command history of what you've done. Ping 5551 -3, and we'll do a count of 3 of them. Okay, so that's working. All right, so now let's turn the set dump back on. Set dump all. And let's do that ping again. Okay, well, set dump question mark. It's set dump detail. That's what we're looking for. Set dump detail. That's like an IP packet detail. All right, now let's do that ping again. There we go. That's what I was looking for. Set dump detail is what we were looking for. So let's go ahead and, after our ping is done here, which I think it's done, set dump off. And starting at the top, we can see the detail we were looking for. So let's go all the way to the top of this TCP stream. Okay, so here was when I did my TCP ping. So here we see source address, destination address, protocol is TCP, acknowledgement number, sequence number, flags. This is the sync. This is the TCP sync. Here's the incoming sync ACK and the ACK. So right here, these three show me all the details of my TCP three-way handshake. And then we can see the push bit and the ACK bit are set. So as you can go through this, you can get a lot more information than you normally could in just a regular debug IP packet within a router using the set dump detail. And once again, set dump off was the way that you turn it off. So there's a lot more that you can do with virtual PCs. I would encourage you to Google VPCS. There's a lot of documentation out there on it. But hopefully in this video, I've given you a good starting point as far as some good ideas as to ways you can use this to test various features and protocols in your topology.